Thank you for joining I Am Possible, which is India's first Future Tech meets sustainability podcast. Today, I'm delighted and honored to have with me Professor V. Ramgopal Rao, who's currently a professor in EE and the immediate past director of IIT Delhi. Dr. Rao served as a P.K. Kelkar Chair Professor for Nanotechnology in the Department of Electrical Engineering and as the Chief Investigator for the Center of Excellence in Nano-Electronic Projects at the IIT Bombay. Dr. Rao has over 480 research publications in the area of nanoscale devices and nanoelectronics and is an inventor of 49 patents and patent applications. Professor Rao is a co-founder of two deep tech startups at IIT Bombay, which is NanoSniff and SoilSense. So, Doctor, really appreciate you taking time and being part of the podcast. There is a deep problem with the education industry itself. The rote education industry has created students who just mug up before examinations, and there's a dearth of skilled laborers, when they actually graduate. So, would you like to address what are the pros? Obviously there's quite a lot. What according to you are the cons of India's education industry, and how do you think you could address it to make it future ready?
Yeah, I think one of the challenges that we face in India is there are of course great institutions like IITs and some of them, and then there are also the other institutions which are second tier, third tier, and I think in IITs, if you see, the employability is not really such a big concern in institutions like IIT Delhi. The reasons for that are because of the nature of the activities that happen in the institution. For example, if you see faculty members here, most of them are researchers themselves. They are always undertaking research which are sponsored by industries or by government agencies or by other organizations. So in the process, what happens is the faculty members develop a social connect, and now when they go to the classroom, many of these sort of social connections that they have developed become anecdotes in the classrooms. And whenever they teach a course, they bring in all of these aspects into the course, and that gives the students a wider, a broader perspective on not just the subject knowledge required to clear the exams, but also the bigger picture of why are they studying something and what is its relevance in the larger context of whatever is happening in the society. I think that aspect is very important because unless we combine research and education together, if we see them as two separate things, they don't really benefit each other. But if we see them as an integrated sort of a activity, that you are conducting research on problems which are affecting the society, and then you are going to the classroom and delivering lectures, not just on the subject matter, but bringing all of that research aspects into the classroom. I think that is what is probably missing in many other institutions in the country, which have basically been just undergraduate institutions, and just all the knowledge is available in textbooks, and which is like a wholesale to a retail kind of a thing. You go to the classroom and every day you dish out a few pages of that. I think that makes the students lose interest in what they are studying, why they are studying, and they are also not able to connect it with the broader kind of things. And in the process, it all has become rote learning, and you study and then you mug up and then you go and write examinations. And I think it has to have it has to do with the institutions first developing that society connect. I think that is when students get connected, and that is when they will become problem solvers, and by becoming problem solvers, they basically become employable and all of that. I think that is what is required, which I see is missing in many of our educational institutions.
Right, I think fair enough. I mean, making children or the students understand that how do you solve a problem first, the culture, the ethos of that, the innovation. I think once we bring that into the education industry in the system, we've got a great future ahead. Now, just recently, I had interviewed Dr. Nanasaheb Thorat, who's a research scientist at University of Oxford, and he's a nanomedicine, nanovaccine specialist, and he's a product of government school, from Nagpur, and he was saying he had this grouse, and he was mentioning that how IITs and the IIMs are the only institute which are being funded. Like even the recent budget, the IITs I think have been allocated around 8,495 crores, while IIMs have been allocated around 653 crores, with very little support for these tier 2, tier 3 rural education institutes. Now you mentioned about the problem with the education industry, but 1.3 billion people in this, and the future is our kids. How do we make the education industry equitable? How do we make sure that the benefits can be reached out for not just the ones who are privileged few, who sit in cities, who have the privilege to go to the IITs and IIMs, but how do we take this same thing for tier 2, tier 3 education industries?
This funding is a national problem right now. Funding education, India is definitely not doing a good job when it comes to funding its educational institutions and even research. Even that, if you look at as a percentage of GDP, the amount of money we are spending, we are stuck at that 0.6 to 0.7% of GDP. And in percentage terms, it's actually going down. So though economy is increasing, so you tend to see a little bit more money every year, but that increase has not been sufficient. And as a percentage of GDP, I said we are at the bottom of the table. If you rank all countries based on their expenditure on education, as a percentage of GDP, India is at the bottom of the table. And other countries, like China, US, Korea, Germany, all of them spend anywhere from 2% to 4% of their GDP on higher education, while India is stuck at that 0.6%. And that is what reflects, in that funding patterns that you see in the country. The general impression is that IITs are receiving more money, than anything else kind of a thing. But, I have been the director of IIT. I had been the director here and for 6 years. And I can tell you the money that government of India gives us mostly goes for salaries and pensions. The salaries and pensions take away almost 70% of money that we currently receive. We receive no money for infrastructure. IIT Delhi today has a loan of almost like 630 crores. So we take loans now from government of India, from banks, and we repay that money back to the banks. And that is the situation right now. So when somebody says that IITs are getting a lot of money, it's because of that lack of information, which is what is causing that sort of a thing. But it's not to say that other institutions should receive more money, but IIT Delhi can today absorb 4 times more money than what it is receiving today. 4 times more money. While we receive 50% of money from the government as a grant, we generate another 50% through sponsored research and all of that. So despite that, I am saying that IIT Delhi can have a grant of almost like 4 times that of what we are actually receiving. If you look at China, for example, the amount of money China is spending on its higher education, just the 2 institutions, you can go to Google and search that, the Peking University and Tsinghua University, their budget for these 2 universities is the entire MHRD budget. And MHRD supports something like 130 institutions today. And so therefore, I think compared to the global scale at which we are expected to operate, particularly IITs, there is intense pressure on us, figuring in the top international rankings and all of that, compared to what China spends on its higher education, compared to what India is doing, I think there is actually no comparison. Like I said, what they spend on 2 universities is what India spends on its 130 universities now, including the IITs and all of that. I think, the point is that we need to spend more money, because higher education is the driver for all knowledge economies of the future. Just imagine US without MIT, Stanford, Berkeley, and all of that. The US doesn't look like the same country, if you take away all these great institutions from the US. And India needs to do that. India needs to build those MITs and Stanfords, and that requires investments in higher education, and not just in IITs, but everywhere else. I think, India needs to spend at least 10 times more than what it is spending today when it comes to its higher education budget. And that will propel our institutions to the global level. And that is when the innovation and all of that will thrive, not just in IITs, but even in universities and colleges in the rural areas and all of that. And, then great things will start to happen in this country. I think there is a need for investing more in higher education in this country, and which I just hope the current government realizes. And it's not about one government versus the other. This has been the situation since independence, and also we cannot also blame the planners all the time, because in a country where there are so many pressing needs, as I always say, if hunger is one of your problems on the list, nothing else can be above that. I think, so I think considering the situation that we are seeing, maybe whatever is happening is currently happening. But if we ever want to build a knowledge economy, if we want to be like the Koreas and the US and Germany kind of developed nations, we have to invest more into our higher education, because these are the institutions which will propel the country in that direction. And that I think needs to happen now. Now time has come for India to start investing, like I said, 10 times more into its higher educational institutions. And in a way, you can always direct the money to do certain things. If you want innovation to thrive, you can always have money, into innovation kind of programs, startups, deep technology startups and all of that. I think if multiple things can be done. If you want IITs to collaborate with rural institutions, there can be separate schemes where IITs are made to work with these rural schemes, where everybody is funded for that. Right now, there are multiple programs for us to do that, but there is no money. Just by preaching that we should all do these things are not going to happen. So we have to invest where our mouth is, and we have to put money where our mouth is. And if we want all of this to happen, if IITs need to groom these smaller institutions and other institutions, we need to create national schemes, fund those national schemes generously. That is when all these great things will start happening. I think time has come for us. India knows how to create good institutions. Even if you look at the newer IITs, the newer IITs have not been created by any Western countries and all of that. They were all created by the existing IITs. IIT Delhi, for example, has created IIT Ropar, and we have also created IIT Jammu. Now, both these institutions have come up very well. IIT Ropar, as you know, now is doing very well, after 12 years or 13 years of being in existence. So we know how to create these great institutions. I think that model exists right now, but we are very poor at sustaining excellence. We are very poor at, taking things to that next level. And we are, I think that is what is missing in the country right now. And I think we need to invest more. I think that point is well taken. But that IITs are getting more money is all, a misconception. Like I said, IIT Delhi today has a loan of 630 crores, which it needs to repay. And 80%, 70 to 80% of the money that we give goes for, scholarships, goes for salaries, goes for pensions. And there is no money for anything else right now in the system.
Professor, thank you for explaining, because yes, I mean, there has been a misconception about that. So thank you for clearing it completely. And I really hope that the education funding, the research funding is doubled up, because you pointed out, there's a glaring difference, 0.6 versus China. And we all say that we need to emulate like China, or we need to emulate America. And the only way we can do it, we've got great minds, because there's plain to see some of the brightest, some of the biggest companies in the world have Indian leaders, but then somehow see that they're completely disconnected. They become foreigners themselves, because there is greener pastures over there and these more opportunities over there. But though, yes, I see that the shift which is happening, because 1.3 billion people, and the opportunities we have here is humongous. If we create a system where we are funding these educational institutes, we're funding education and healthcare also, which I think is the basic of creating a better nation, because if we take care of that, I think the rest will automatically fall in place. Now, over the period of this decade, I think tech has come to play such a huge role in education. There's EdTech and there's augmented reality, virtual reality, which is taking us from passive learning to interactive experiential learning, because learning is best done when you experience it rather than just reading about some things. And then there's artificial intelligence, which is being leveraged for personalized learning. So what, according to you, is going to be the future of learning, and what's the role of technology over there?
Yeah, I think lots of things are changing, which is the one major change that you see today, in terms of the evolution of education is the student-centric kind of a model. Like Industry 4.0, there is also an evolution in education, like Education 1.0 to Education 4.0. Now, in the current era, it's all student-centric kind of learning. Student is at the center of everything, and the student is connected to teachers in the classrooms, student is connected to the online resources, student is connected to his or her peers, and student is connected to the outside world, and that is how student is receiving all of this information from various quarters. The job of teachers is to basically clear doubts, and basically tell the student what is the right information, what is the wrong information, help the student organize information in a way which makes sense at the end of the day. And I think that is a kind of a model that we are all looking at. And in fact, very often I see that now students are saying, why do I need to come to the classroom if the lecture is available online? I can as well go and listen to that lecture at my own pace and at my own preference in terms of time and all that, rather than who says that 8 to 9 I must study chemistry, 9 to 10 I must study physics, 10 to 11 I should study math and everything. I can do that at my own pace, and therefore why are you even insisting that I should come to the classroom? I think that is now putting immense pressure on the teachers. So now if you want to attract students to the classroom, you cannot just by teaching from textbooks and then expect them to come and listen to you. So you need to innovate. The teachers need to innovate. And unfortunately, if you look at how much the teachers have been able to adapt to all these new technologies, that has been pathetic. If you look at, in fact, I always tell this joke about a teacher and a medical practitioner, a medical doctor. So I think the story, the way it goes is a teacher and a medical practitioner both go into coma, right? And then after 30 years, they come back to their senses. Now, after 30 years, when they come back, the medical doctor goes to the hospital and goes to the operation theater. Everything has changed. Now robots are performing surgeries, and there are so many new types of instruments doing so many new things, and our medical doctor is completely lost, because the medicine has completely changed now or transformed. Now, on the other hand, our teacher goes to the classroom, takes the chalk and starts giving lecture. Nothing has changed in 30 years. The only thing that has changed probably is instead of chalk and board, now many people start using PowerPoint, right? Other than PowerPoint, show me one technology which has really pervaded our lives, in terms of teaching. I think that is the situation. But thanks to COVID, I think one thing that has now become different because of COVID is it has brought people out of their comfort zones, and people who have never lectured or recorded anything online, they all had no choice but to actually do that. So now we see that at IIT Delhi, in just a matter of 8 months after COVID struck us, we have like 700 courses which are online, and by end of year we have like 1400 courses which are online. Now the question is, what do we do with all this online material that has got created? Can we start to organize this in a fashion where we can give diplomas, where we can run online programs? Because our education model in the country has been, at least for IITs, is you conduct the world's toughest examinations, and then so many people take the exam, a handful of them clear the exam, they enter the IIT system. Once they enter, there is no exit barrier. Anybody who enters IIT will actually exit, because you come here and then you clear the exams, and it's all so easy for them because these are all such intelligent people anyway. So now many of them, 99% of them, go clear the everything and then exit the campuses. That has been the model, and because of that model, the education has not scaled up. This quality education has not scaled up. one thing which COVID has taught us is, now that we we can deliver lectures online, now that all of that can be done very effectively, without compromising on the quality. So can we can we remove those entry barriers, rather create more exit barriers? After all, we are all very brand conscious. So now you allow more and more people to enter the system, right? Without having to, take any examinations and all that, and take some courses online, spend some time on the campus during summers or breaks or whatever it is. And at the end of the day, you don't want to give IIT degrees or certificates to everyone. So therefore you conduct an exam, and those who have done well, they actually eventually become, get those diplomas or certificates and exit, with a degree or diploma or certificate from IIT. So that kind of an inverted model of education is what is possible now. And it has become possible simply because now those barriers for, doing anything online, they have gone. Until that time, we thought that anything online is inferior to anything which is, in the classroom kind of a thing. So now we have realized that it need not be so. I think with a proper kind of training and planning, you can make the online programs as good as the classroom programs. And it may not work in all areas. After all, engineering, you also learn by doing. So therefore, giving engineering degrees may not happen, but there are areas which you can fully pick and choose. And then in those programs, you don't need to, unnecessarily make somebody, come to the classroom and then, sit and learn there. Rather, you can create these online platforms. So we did that, about a couple of years ago. We started an e-Vidya platform from IIT Delhi. Within a year, it was able to reach almost like 3,500 students, give certificates to 3,500 students, in variety of areas. And it has been a hugely successful kind of a program. And using offline classroom kind of a model, we could never have scaled things in such a short time to those kind of levels. I think, things are changing now from that point of view, and hopefully that model will continue to prosper and will continue to scale further. Already IIT Madras is doing a bachelor's in science program, which is entirely online and with large number of registrations. IIT Delhi is doing lots of certificate programs. Like I said, in a year, thousands of students are benefiting from these certificate programs. I think these models are evolving now out of IIT, and that is a good thing, because that is what helps the quality education to scale. And because IITs often have been associated with that quality, our certificates are valued outside. And now if we are able to scale and more people can benefit, there is nothing better than that.
Lovely. Yes, I think there's an evolution of sorts, and tech is playing such a huge role. I think virtual reality, which is in such a nascent stage, it comes with its own problem because the devices are expensive and there's not much of content. But eventually, I think, it's going to become possibly as light as this, and maybe then there are already companies which are working on augmented reality lenses. So the future of education is going to be experiential with haptic feedbacks and stuff like that. You'll be able to actually touch, feel, and experience things, exactly like how we touch, feel things in a physical world. And this evolution or transition from a Web 2.0 to Web 3.0 with the metaverse and everything converging with artificial intelligence, personalized learning, I think it's going to be superbly awesome. Yes, I think it's going to threaten also the status quo, because these brick and mortar education system has been the grounding for all the education for everyone. But somehow this MOOCs, massive open online courses, it's creating a paradigm change in itself, because education, which was is becoming free and accessible for everyone. And on the other hand, India has somewhere around 84,000 outstanding student debt loans. So I think, yes, I mean, the democratization of education, which you said IITs are doing through, you mentioned your e-Vidya platform, and then you mentioned how all your 700 courses which you went online, then 1,400 courses which are going online. I think that's a great way to democratizing these the education and the education industry. Would you also like to comment on certificates versus skills? Because Elon Musk, keeps on claiming that, he is not looking at degrees, he's looking at skilled workers, and somehow there seems to be a shortage of skilled workers. Would you like to address that problem?
I think this has been one challenge in the country. Education, for whatever reason it is less hands-on, and more classroom kind of a thing. That is how things have evolved, and which is something which are now beginning to correct in at least in IITs. For example, we have a major curriculum review that is underway, and in all of that we are introducing tutorials. Every course will have a practical component, and in many courses today students do course projects, and where they have to build something or develop some tool and all of that. I think that is now beginning to happen, but it is, I don't look at it as a debate between degrees versus skills kind of a thing. Both of them can be combined together, and degrees need not necessarily mean that you only become good at theory and bad in practice kind of a thing, whereas skills would mean you are only good at something, bad in theory kind of a thing. I think all of that can go hand in hand, and can be in a way meshed to give the best experience to the student. In many areas, in IITs, for example, why is it that so many IIT graduates are successful in so many diverse fields all over the world? The reason for that is the kind of emphasis we have on the fundamentals. So the IIT education, you join any engineering program in IIT, you will be taught enough of physics, enough of chemistry, enough of mathematics, and these are the founding. Now these days, enough of biology too. I think we start with math, physics, chemistry, and biology, and there every student becomes comfortable in these subjects first, and then we start teaching the real engineering programs and all of that. That grounding in the fundamentals, and that ability to think beyond just putting things together from looking at YouTube videos and all that. I think we go beyond that, and then that is one reason why IIT students do very well wherever they go, because they can connect. Once your foundation is strong in all these areas, then you can go and connect these strong links to anything else that you are doing. Whether you become an automobile engineer or an IT specialist, you tend to innovate, you tend to do better than others because your grounding is very strong kind of a thing. I think that is the way, in my opinion, how education should be. If you want to even build the future sustainability, sort of models in anything that you are looking at, I think these fundamentals are going to serve you very well, rather than some jugaad kind of an approach that you buy these components and put it together. I think that can only take you so far. I mean, if you define skills as putting things together, I think you become trained for something and you do that job. But when new areas emerge, because every 5 years, every 10 years, lots of things change, and the ability to learn these new areas and that is a big the continuous learning, the continuous education. These things have become more important now than ever. And if you are only skilled very narrowly in one area, and if things change tomorrow, you will not be able to again go back, and your ability to pick up those new skills may not be all that great. So though one cannot generalize all of that, but on the other hand, look at an IIT graduate who is trained in all these fundamentals and who has the confidence that he or she can learn any new area, because that learning aspect is what we emphasize so much in the education here. And when something changes, the student can easily go and pick up those skills and move on and become better at whatever they do. I think that is where the degree programs need to be. That is where our curriculum needs to focus on, that ability to learn. I think that is what we need to emphasize more than just some skill training in some small area and all that. That may be okay for a large section of people, but I would like to see students coming out of our premier institutions go beyond just simple skills kind of a thing. They need to be able to plan ahead, and they need to be able to become leaders in any area that emerges in the future. And for that ability to learn is what is more important than anything else.
Now, you have been vested in nanotechnology and nanoelectronics, and you are also an inventor of 49 patents, and those patents have been leveraged for industries. So for my listeners, can you first explain what is nanotechnology and how is it being used right now? Maybe also talk about a few applications of nanotech.
A lot of things are changing now in nano. Nano basically is you have all these materials in the periodic table. The way the nanotechnology evolved is, you look at all these elements in the periodic table, the copper, zinc, magnesium, potassium, all these kinds of elements. And then, what you see as properties associated with these elements are all usually the bulk properties of these materials. But now if you take any of these materials and then, make the particle sizes smaller and smaller. Let us say, what you study is what 100 micron gold particle looks like. Its color, its electrical conductivity, its optical properties, mechanical properties. All these properties that you study in textbooks are when the gold particles are 10 micrometer size, 100 micrometer size, and then you make materials out of that. Now the same gold, you take it to, let's say, a 5 nanometer size, the particle size, or 10 nanometer size. That is when things start to change. These materials now, because the classical physics breaks down at those length scales, the quantum mechanical effects come in, and these materials now start to acquire very new properties. For example, gold doesn't even look yellow, when it is 5 nanometer size, and its electrical conductivity, its all other properties tend to change. And the same happens with almost every element in the periodic table. So that is what excited the nano scientists, because they said, if these materials are now behaving very differently at the nanoscale, and then can we first understand these properties, how these properties change as a function of the size of these particles. A 5 nanometer gold, a 20 nanometer gold do not behave the same way. Now they become very strongly dependent on the size of those particles. So therefore, can we understand the theory behind that? Can we predict these material properties at the nanoscale using theory and understanding of all of these quantum mechanics that is taking over at those length scales? So now you can imagine it's a great science. So now you have all these elements in the periodic table. Now they are all behaving very differently at the 5 nanometer, 10 nanometer kind of length scales. So understanding the phenomena and even engineering these materials. For example, for a particular application, I want certain properties for these materials. Now, can you go and arrange these atoms in a way? Because in nano, now you are getting down to the nano scale, which is like the dealing with the atoms now. So can I arrange these atoms in a way, where I can achieve those properties? So meaning you are almost playing God now. So now you are creating materials which are required, to meet certain properties. So therefore, it has evolved into a great science. And once there is a great science, then the engineers often get excited, because now as an engineer, when I look at these materials, now I see all these new properties. Therefore, can I use these properties for new applications? And that is where the applications now started appearing in the market, with which are based on these new properties the materials exhibit at the nanoscale. And for example, there are today lots of textiles. In the textile department at IIT Delhi, there is a large team of people working on nano coatings for the textiles. They have already licensed these technologies to multiple companies and all of that. And these nano coatings, for example, you can have shirts which are stain resistant. So now even if I spill coffee on my shirt, nothing will happen, because it will have that lotus leaf kind of an effect given to the shirt. That way, spilling coffee, no stain will occur. And similarly, technical textiles. You can make now these textiles, antimicrobial, antiviral, those kind of coatings you can apply. For example, one of the very early developments in the IIT Delhi textile department was these high quality masks with the nano coatings. What these nano coatings basically do is, when the virus comes in contact, it can destroy that virus. So these are all antimicrobial, antiviral kind of a thing. And then people are using it in biotech, in the medicine field, the targeted drug delivery, for cancer treatment. Can you attach the cancer drug to the nanoparticles and direct these nanoparticles to go and deliver the drug to the cancerous cells without affecting the healthy cells? That way you can treat cancer in more advanced stages, because now you are able to selectively deliver the drug to the cancerous cells. So the targeted drug delivery, many FDA approvals have already been obtained, and many patients are benefiting from that. So as you can see, from textiles to automobiles to medicine, you name, every area now is getting impacted by the nanotechnology. And from coatings, now we are moving to devices. One of my startups has also looked at the nano sniffer. We have been able to launch that product recently. We have worked on sensors where the nano mechanical motions are used to discover, are used to sense, certain material, certain kinds of, analytes. So all of that can be done now. So from materials to devices to systems, that transition is taking place. There are over a dozen companies in India which are now in the nanotechnology space, and I have two of those companies now. So things are looking very good, and a lot of knowledge is happening. India is ranked third in the world when it comes to nanotechnology knowledge generation. So now the knowledge to wealth creation is beginning to happen. So I think exciting times now. So as a science, it's a great science, and as an engineering, nano engineering. So now we are all, trying to get products out into the market, and many things are already, making good business now. But all these startups, which have been able to put products together based on the nano science, I'm sure some of them will become big companies in the near future.
Lovely. How cool is that? Because you mentioned in the course of conversation that we've got the tool to tinker around and play God, because everything is made out of atoms, and when atoms they clunk, now it creates everything that we see, perceive, not just what we are made out of, or environment and the universe. And to be able to tinker around and create these magical applications is super awesome. Because you said, right from these textiles, nano coated textiles that IIT Delhi is looking at, to these healthcare applications, it's going to completely upend how we live, work, and play. And yes, there is certain side of me is a little worried, because people in general are not are very averse to change, and they've built these blinkers on what can or what we humans cannot do. Now with all of these technologies, I think we are probing the boundaries of what was termed possible and what was termed impossible, and those which was termed impossible are the things which we are able to probe, with your nanotechnology, to quantum computing, to artificial intelligence, to virtual reality. I think all of these stack is going to create a world which is going to take us to that Arthur C. Clarke quote, that technology is akin to magic. So I think we are going in that world. You were also mentioning about gold. When it goes to nanometer size, it starts behaving weird. The quantum mechanical property starts going into it. There is something called as, these great minds are spoken about, is a nanoassembler. That someday we would be able to create a nanoassembler, a 3D printer of sorts, where we'll be able to print out anything and everything, right from your gold to diamonds or anything. Because if you go deep down, everything is made out of atoms. So is a nanoassembler possible? And if it is possible, what would it take to build a nano? I know it's a little funky and it's a very futuristic question, but since you are vested in nanoelectronics, I thought I would pose this question to you.
It's an interesting thought. Today, for example, there's a lot of theory required even to understand when the material sizes change, how it impacts the properties. I think once you have that understanding that, if this size and this orientation of the material will give me these properties. So once we are able to understand that science, the next step is to, go reverse. And then, you have these properties. Now, can I put these molecules in this fashion? I think that is the next step to follow. So we are not there yet. I think though people have demonstrated that they can organize or arrange these atoms in a way, that they want to see. But I think that kind of a control on, what sort of arrangements will give you what properties, and, can we do it on a larger scale? I think these are the questions that scientists are all asking. And one of the things that, even my group has explored, or is where I still have an interest, is the molecular electronics. So now if you see the conventional, semiconductor industries, you take a large piece of silicon and you keep, making smaller and smaller dimensions, which is what we call a top-down approach. So you start chiseling away what you don't require, and finally end up with a device which is like 5 nanometers, 10 nanometers, which is made out of, all these large bulky kind of things. So that is a top-down kind of an engineering that silicon industry, the semiconductor industry currently follows. one of the questions that, many of us are asking is, why do you need to do that? Can you start with molecules, for example, and use these molecules to perform the same functions as a transistor? In electronics, the heart of every semiconductor chip is what we call a transistor, and which is what drives the entire semiconductor industry. But that is chiseled out of a larger kind of a piece of silicon, and then you make those devices by removing things selectively. But what we are asking is, why to take such a larger thing and make it smaller? Why not start with molecules and make these molecules to behave like transistors, and then assemble these molecules together to reach bigger kind of systems? For example, an AND gate, OR gate, or your microprocessor, compiler. Can we do all of that any larger system by using these molecules, by arranging these molecules in a certain fashion? So that is what a bottom-up kind of an approach. So now in a bottom-up kind of an approach, the scaling up is a challenge. I know how to make one molecule work like a transistor, but I cannot connect tens or millions of molecules together to make a complete system out of that. So that scale up is a big challenge. On the other hand, what the semiconductor industry today is struggling is the scaling down. They know how to make it up to, let's say, 10 nanometer kind of a thing, or even 5 nanometer sort of devices people are talking about. But can I go down to 1 nanometer? Can I go down to angstrom kind of length? So scaling down is a problem with the conventional electronics, while with molecular electronics, the scaling up is a problem. So I think both of these are challenges right now. And much of my work also focused on putting these two things together. Don't look at them as independently. You use the conventional silicon technologies, but you also add on to that some bottom-up kind of an approaches to enhance the performance of silicon chips by using self-assembled monolayers, by making these molecules assemble in a certain way in a silicon device. Can we enhance the performance of these silicon devices? So we are looking at a place where the bottom-up approaches and the top-down approaches come together to give a better quality kind of a device which can be useful for the future nano electronics. So there are all these kinds of approaches which are happening, and it's a very wide open kind of a research area. And molecular electronics, I think it will get a Nobel Prize one day, when people are able to figure out how to connect these molecules and how to make larger systems. And if somebody can demonstrate all the common functions using such molecules, I think that's a Nobel Prize winning work today. And this is a lot of work happening both in India and elsewhere. Let us hope some of these will become a reality soon.
Right. Yeah, there's some really great work happening, and I hope that those great innovations comes out of India. So thank you, Professor. Really appreciate you taking time and being part of the podcast. My last question to you. I'm sure you have a dream. We all dream of a better India. What do you think would be your advice to students or entrepreneurs to reach that dream, to create that India which is really, great with education, where it's funded well and we are creating world-class innovation?
I think one thing which is required for us to when we reach 2035 is to keep the sustainability on our radar. As an engineer, I can build a device. Let's say if I am working in agriculture area, I can make these billion sensors. But all these billion sensors are going to get into soil and erode the quality of the soil, eventually remain as things which are unwanted, as foreign material there. I'm not being a good engineer. So I think we need to start looking at putting sustainability first. I think we have one planet after all. And if we start polluting it and degrading it the way we are doing, already we are seeing Delhi had 49.5 degrees centigrade kind of temperature. I think everywhere in the world there are these climate fluctuations that we are all experiencing now. I think we are at some point tip that equilibrium that the nature has beyond a point where it cannot correct itself. When we reach that stage, it's going to be disastrous for everybody, not only for us, but even for the future generations. I think as engineers, we need to put sustainability ahead of anything else. We need to see that whatever we are developing, eventually doesn't harm the environment in any way. For example, we need to learn from the nature. Nature doesn't generate any waste. the output of one process goes as input of another process. And that is the circular kind of an engineering that we need to get into. Whereas all the things that we do, we never look at the complete life cycle of these products. And in the process, we are degrading everything. The oceans are seeing a lot of these microplastics now, and which the fish, you find them in fish and we eat them again. I think it's giving rise to lots of challenges in every sector. I think to me, becoming an engineer who also is concerned about environment, overall the health of the planet. I think that is the education that we need to impart to our children. I might be good at building a bridge, but if I am very poor at understanding how that bridge will impact the sustainability in that region, how it will displace people, how it will impact the entire, ecology in that region, I am failing in my duty. So I think we need we need education now, which will give that all-round knowledge to our students, so that they can connect all these pieces and eventually develop technologies, develop systems that makes the quality of life better and makes India a kind of a developed country in all respects, but without harming the environment like what these developed nations have done. I think if our future should lie in sustainable growth, not growth at any cost.
Thank you, Professor. I mean, that was really profound, because yes, I think we are in excitement and race to just solve a problem. When we end up creating another problem, to go to a place where we can create a circular, sustainable economy is so important. Really, really appreciate you taking time being part of the podcast. It was a learning experience for me, and I'm sure it's going to be for all the listeners. Wish you the very best. And to my listeners, if you like what you see in here, then please press the subscribe button. Until next time, see you guys. Thank you, Professor. Really appreciate it.
Thanks a lot. Nice talk.